Welcome to Real Civil YouTube channel. In this video, I am going to here I am going to start a new series of how to analyze and design building in ETABS, right from architectural drawing to how we can model it in ETABS, analyze it and design it. So all these things we are going to see. So the first step in RCC design or any structural design for building, you will get the architectural plan. So here you can see we have one architectural plan here. So from this architectural plan, we have to convert this into beam column framing layout. So this is the first step, and then we can go to any software. Especially here we are going to see it in ETABS software. So how to prepare a beam column framing, I am going to teach you in this video. Okay, so first of all, I will copy this plan. Okay, then we will create a new layer. So for that, you can go to layer, and here there is option of new layer. In new layer, first we can write beam grid line, and you can select the color. Okay, now here we'll select the beam grid line. So basically what we want to do here is we want to frame the beam grid line, means where we want to put our beams. So mostly the beams are under the walls. So let's start the drawing. So first of all, I will mark the outer beams. Okay, then here we need a beam. You can see these are all the walls. Along the walls I am drawing these beams. Again here there is a beam wall, so we have to will require a beam here. Then okay, again here also there is a beam, because there is a wall here. Then here we will require a beam. I will extend this. Again I will require a beam here. Okay, now we will give the offset. That means we are assuming that our beam width will be of 9 inch. So let's give the offset of 9 inch. Then here 9 inch offset. Then okay, so we are drawing the beams in our plan. So again offset, yes. Now I think our beam grid line is ready. So what you can do, simply you can off other grids like this, copy this, separately. Okay, now you can on the grid lines. Okay, now we can work here. Now this is our beam. Okay, one is missing here. There is a staircase, so we'll require, I will extend this. Yes, now it's okay. uh, we'll make this slab separate, this slab separate. Okay, so this is how you need to make the beam grid line in your plan. So you have to study your plan. Where are the walls, how you want to rest your beams, primary, secondary. Okay, now our next task is we have to place the columns. Okay, to place the columns, again we will create a new layer. Go to here, new layer, we'll name it as a column. We'll select a red color. Okay, now let's assume that our column will be 9" by 15". So select the column layer here, 9" by 15". 9" by 15". Okay, so now I will copy this column, because sometimes we need to orient this column. So yes, now we have to place these columns in our plan. So let's place these columns. So I will place one column here, then the second one, the third one, the fourth one. Okay, then again I will copy this, place at this point, again at this point, then at this point. So this is your, as per experience you will get, if they have given the column position in architectural drawing, so you can refer those column locations also. So one column I am putting in this way, so you will come to know how in ETAB we change the column orientation. Sorry. Yes, now my beam column framing is ready. Now we will prepare the center line of the beam. So here I will create beam center line. Okay, so as we have 9" beam, we will require an offset of 4.5". So we'll put the offsets like this. Okay, now I will match this center line property to the beam center line. Yes, now we can copy this center line. For that we need to turn off the beam and column grid line. Now you can simply copy this. Okay, now you can turn on the grid lines if you want. Okay, now we'll trim these parts or extend if required. Okay, so first check all the joints. Yes, it's perfect. So this is the center line which we will uh, there are multiple ways to work in ETAB. You can either import this or you can go through grid line option in ETAB. I think that is the best option. For that you need the spacing. So all these are in inches, no worry, we can convert this directly in ETAB. So first we'll mark, or I will use different color. Yes, this is 219 inches. All these grid lines we can make in ETAB using these spacing distance. Okay, so I think in X direction, yes, this distance will required. Just a minute. Yes, so in X direction this grid line will be at 0, this grid line will be at 219 inches, and there will be another grid line at 129 inches, and then again all these grid lines will mark in ETAB software. You can basically change the font size through this dimension style, like text height you can change. So that all these units dimensions will be visible to us. So today we will model the plan in our ETAB software. So there are multiple ways of doing it. So in this part I am going to tell you two ways how to import this model or how to prepare the grid line. So Before that, we'll make one change here. Instead of putting this distance, we'll put this dimension from here to here. Yes. Okay. So let's begin with the first step or first way of creating grid line in ETAB. So open the ETAB software, go to files, new model. Here use built-in setting. Here we have to select SI unit because we work in SI units in India. Then Indian steel, we use IS 800 2007 and IS 456 for concrete design. Click on OK. Now here we make the grid lines to draw the beam, column and slab. So these are the reference lines we have to prepare. So you have to choose this option, custom grid spacing. Go to edit grid data. There are two options available. You can work it as an ordinate or you can work it as a spacing. So if you see this, we have put the spacings, right? So we'll select the option spacing. Okay. Now let's put this spacing in X and Y grid data. So first always keep 0. Okay. Second, here 129 and this is in inches. So no worries. We'll just put inch sign and it will automatically convert it to meter. Then 90 inch. Yes. Now let's go to Y. Here you can see 1, 2, 3, 4, 5, 6, means 7 grid IDs will required. So as I told you, keep the first one 0. Second, here you can see 159 inch. So 159 inch. Then 141 inch. Here just type this value, assign the inch sign and press enter. 57 inch, then 54 and 42. 54 inch, 42 inch. Yes, now you can see here our reference lines are ready, so we can easily draw the columns and beams and also the slabs. Click on OK. This is related to the plan. For elevation or story, there are number of stories in our building, but to begin with we'll keep it as 1. I will tell you why I'm keeping it 1 and how to replicate later. So just keep like this, typical story height and bottom story height. As we have one number of story, we will keep 3 meter. Okay, then I will tell you later once we prepare our floor correctly and then we will replicate it. Why I am doing this, I will tell you later. Click on OK. Now here you can see your grid lines are ready. Now you can put or draw the beams and columns. Okay, so I am doing only one change here. We'll create another column here. Okay, because it is a staircase, so let's go with the 4 columns. Okay, now before drawing the beams columns, we have to define the material and the cross section. So go to define material properties. We'll define 2 materials here. First one is the concrete and second one is the steel. So go to add new material, select India, select concrete. Here you can choose the grade of concrete. For our project, we will select M25 grade concrete. If you click OK, the data is already there by default in ETABS software. You can verify these values as per the manual calculation. Okay, Like modulus of elasticity E, the formula is given in IS 456, that is 5000 root of FCK. So you can cross verify all these values are correct or not. Click on OK. We'll add the rebar. Here still we have to select it as a rebar, and then there are multiple grades available. So we'll select HYSD grade. You can select 550 also. Click on OK. Again, the properties related to the HYSD 500 are there, like material weight, mechanical properties, and you can verify these values with manual values available in the books. Click on OK. Click on OK. Now we'll define the section properties. Frame section, add new property, concrete rectangular. So first we will define the column of 230 by 380 mm. So this is the name. Here select M25. Here select the depth 380 and width 230. Now go to modify show rebar. Now we want to design this cross section as a column with longitudinal rebar and confinement rebar, which we have defined HYSD. Keep the remaining things as it is. Click on OK. Click on OK. Similarly, we have to create beam 230 by 300 mm. Material which we have defined M25, depth 300, width 230. Now we want this cross section to be designed as a beam. So select here beam and select the reinforcement which we have prepared or which we have created. Here cover to longitudinal rebar group centroid. So let's assume 25 mm cover with 8 mm stirrup with 16 mm longitudinal rebar. So half means at the center we will be at 8 mm. So similarly it will be 41. Click on OK. Click on OK. Click on OK. Now we have to draw the columns and beams. So go to draw. Here there is option quick draw column. Here you have to select the property which you have defined, that is column 230 by 380. Now here you can see the column positions. Okay, so there are two columns. Then there are three columns in the next row. Okay, again there are three columns in the next row. Okay, now in this row, this is the column at last, that is here, and then again another column is there, and then next to that grid there is another column. Okay, so this is how you can mark the columns, and I will tell you how to change this column orientation later. Let's draw the beam. So go to draw. Here draw beam option is there, and we have to select the property of beam 230 by 300, and let's draw these beams. Sorry, you can right click basically so that your command remains active. So these grid lines help us to draw the columns and beams comfortably. Now there are secondary beams here. Okay, so you can check the beam grid line column locations and the column locations and beams drawn in ETAB. If they are okay, then you can go for basically drawing of the slab. So you can go to define. First we have to define the section property, that is the slab section. So go to add new property. Here we will define slab of 120 mm thick and we'll create two slabs. One will be one way and another will be two way. So mention one way 25. Select here membrane and then as it is one way we have to click on use special one way load distribution. Give the thickness here, that is 120. Click on OK. Similarly, add copy of the property slab 120 mm. Let's define this as a two-way. So for two-way, you have to uncheck this option. The remaining things are as it is because we have copied this. Click on OK. You can create one more slab, say of 150 mm for staircase. Okay, M25 membrane. Again, staircase slab is a one-way slab, so one way 150. Click on OK. Click on OK. Now we can draw the slab. Here there are multiple options available, but you should select the first one. Here now most of these slabs are two-way slabs, so we will select this option and then you have to select the corners. Yes, this is how our slab is created. Sorry, this is our one-way staircase slab. So escape it, go to again draw. Make sure it is slab 120 mm two-way. You have to check actually which slabs are one way, which slabs are two way. If the ratio is more than 2, you can go for one way slab. If it is less than 2 or 2, go for two way slab. Okay, now this is our staircase slab. So go to draw. Here we have to select staircase slab. Now we have modeled all the slabs. Now you can see our staircase is spanning like this. Means our load will be distributed to this and this beam. Okay. That means on these two beams our load needs to be distributed. Right now the load is distributing on these two beams, which is incorrect. So we have to correct the orientation of the load distribution. Similarly, this column and this column, you can see it is vertical, here it is horizontal. So let's change their orientation. So select the column, go to assign frame, here local axis, and we have to rotate this by 90 degree. Click on apply, click on OK. Now you can see the column orientation is changed. Similarly, we'll select this slab, we'll go to assign shell local axis. Again we will change, rotate this by 90 degree. Okay, now again you can see the now the load will be distributed on these two beams. Okay, now one more thing, before showing the second way. Here you can see these beams are secondary beams. So we have to release the moment. So go to assign frame releases, and we'll release them so that they will act as a point load. Similarly, for this beam, we have to check it is a start point or end point. Let's do one trial here. I assume it is a start. Yes. And similarly for these two beams also, we want them to act as a simply support beam at the end. So we'll say we'll release the end only. Yes. For this beam also. Okay. So now our model part is over. Next part is of load calculation, which is very important. Before that, I will save this model. Okay, as I told you, I am going to show you another way of doing this or importing the plan. For that, what we need to do is we need to copy this. So I will just off this layer. I will only copy this center line. Control C, open another AutoCAD file like this. This is more simpler way. Start drawing. Here units will be architectural, as our drawing is in inches. So select feet and inches, and here it will be inches. Click on OK. Now we'll paste Control V here. Now I will put this at the 0,0, that is at the center of this sheet. So let's draw one line from 0,0. So L enter, 0,0 enter. So here we get the starting point. So just simply move this here. Okay, now we can delete this line. Now we'll save this file as a DXF file in the location you want. I will save in ETAB course. Okay, so make sure it is DXF 2007. Save, close, Now open a new ETAB model. I'm showing you another way of importing. This is much faster way of doing it, but you should know all the ways. There are two more ways actually, but we'll discuss later. So go to File, New Model, use built-in setting. Now these are we have already defined. Now for this method you have to select this as a blank, and here keep the story 1. Remaining steps are same, just I will tell you what you have done in last method is you have put the grid spacings. Okay, now here you have to go to File, Import, and you have to come to DXF architectural grid, and this is what we have saved right now. Open. Our DXF file was in inches, and we want to copy the beam center line. If you remember, we have created this layer. Global up direction is Z. Click on OK. Before that, we have to save this model. Now here you can see this grid line what we have prepared in AutoCAD is readily available here, and you have to repeat the steps for material property and section property, and you can start drawing here also. So this is how this is the second way of importing. So I'll just show you one. I am not defining anything, just I will show you any column here it will be. See here you can see like this. Okay, remaining steps are same. Instead of putting in the grid spacing, you can directly import, and now you have to repeat same steps like define the section property, column properties, beam properties, material properties, slab property, and draw it here with this grid line. So this is much faster way of doing. So we have covered the modeling part for the ground floor. I will tell you how to replicate this model, this floor to other floors. But right now I am working on only one floor. The reason behind this is once your this floor is perfectly modeled, perfectly loaded, then you can check if any error is there. If not, then you can replicate. Otherwise, what happen if you are working simultaneously on multiple stories, then if any mistake you have done while modeling for a particular floor, that will get replicated to other floors, and then so many errors will come, and it will be difficult for you to resolve those errors. So it is better you work on a single floor, check that single floor, if it is okay then replicate. Okay, so we have created this model, this plan, mark column, beam, slabs, how to rotate, column orientation, slab orientation we have discussed. Even this slab can be uh, one way, because you can see it is almost double. So how to change? So select this slab, go to assign, shell. Here you have to select the slab section, and we will assign one way, apply, OK. Now similarly the load is distributed on those beams which are closer, so we have to change the orientation. So select, go to assign, shell, local axis 90 degree. Okay, now we are going to start a very important part, that is of loading. So let me open the file. I will explain from very basic. So in ETABS software, or for this session, we are going to assign the loads. Okay, so these many loads we are going to cover. First one is the dead load, second one is live load, floor finish, then sunken area load, and masonry wall load. So all these loads we are going to cover. Okay, so let's begin with dead load. So what do you mean by dead load, or what ETAP considers the dead load? So you can see here that dead load is nothing but the self-weight. In ETAP, the meaning of dead load is self-weight of the member. So in our plan, or in our ETAP, you can see we have modeled slab, beam, column. So no need to assign the self-weight. Once you select the dead load, then automatically ETAP calculates its self-weight. Okay, we know that how to calculate the self-weight of the structure. For example, here I have shown one example, that is, suppose this is the beam 230 by 450 mm, and suppose this is the length of the beam. Then how to calculate the self-weight of the structure, you can see here. I will zoom. So you can see dead load is equal to volume into density. So the volume is 0.23 by 0.45, it is the cross section. Here you can see, and 25 is the density of the concrete, and we calculate per meter. Okay, so into 25 into 1. So from where we get this 25 value, that is important. So this value you can get from code IS 875 part 1. Okay, so I will show you that code also. So this knowledge is very important. So interviewer, or in your external exam, the examiner may ask from where you have get these values. So there is a code IS 875 part 1 1987, code of practice for design load other than earthquake for building and structures. So here you can see part 1, dead load, unit weight of building material and stored material. So using this code we get all these values. Okay, so let's see. You just need to scroll down and you can see there are various materials are available and their densities are given. So remember, if anyone asks you about from where you get the value, so you can tell them that I have referred IS 875 part 1, where the unit weight or densities of the materials are given. From that I have taken. Okay, so here you can see cement, concrete, reinforced, cement, concrete, pre-stressed. So all the values are given here. Cement mortar, what should be value? Okay, so the ranges are given. So we consider it is 25. Okay, so 0.23 into 0.45 into 25 into 1 is equal to 2.5875 kilonewton per meter. So this calculation it have done on its own. Okay, so for that you have to come, open ETABS software. Here you have to come to define load pattern. Now by default there is a dead load, type is dead, self-fit multiplier is 1. We have to keep the self-fit multiplier 1 for the dead load case. So whatever members you draw, ETAB calculates its self-fit on its own. Okay. Second case is also there, live, or you can type here live, select live, make sure the self-fit multiplier is 0. Okay. So what is live load? That needs to be very clear. So many times students are unable to tell what is live load. So here you can see live loads are the movable loads or something that can't be fixed at one place. Like human beings, we move here and there. Our furniture, table, bed, etc. Those things we change their positions. Okay. So they are considered as a live load. So where we can get these values? So for that there is a code book, that is IS 875 part 2 imposed loads. So this code has given the values of live load to consider depending upon the occupancy requirement. Okay. So let's open this code, and basically the value depends upon occupancy requirement. So let's open the code. So here you can see this is the code IS 875 part 2 code of practice for design loads other than earthquake for building and structures part 2 imposed loads. Okay. So I'll clear this and let's move. Let's see what is given in the code. So here you can see table 1 imposed a floor load for different occupancies. So here you can see there are different categories are given: residential building, hotels, boarding houses. So different types of buildings are given. So let's focus on our residential building. For residential building, for all the rooms and kitchen, the live load value is 2 kilonewton per meter square. Okay. For toilet and bathroom, the value again 2 kilonewton per meter square. For corridors, passages, staircase, including fire escape and storerooms, 3 kilonewton per meter square. Balconies, 3 kilonewton per meter square. So if any interviewer or in external examiner asks you how you taken these live load values, so you can give the reference of this code. So depending upon the occupancy, code has given the values. Okay. So let's assign these values, and these values are the floor loads, that is unit is kilonewton per meter square. So let's come to our ETAB model. So before that we have to see our plan. Okay. In plan you can see this is our hall, this is kitchen, this is bedroom, balcony, bathroom, WC, and staircase. So based on the occupancy you can give the loads. So for hall, kitchen, bedroom, okay, bathroom, WC, the live load is 2 kilonewton per meter square. For staircase it is 3 kilonewton per meter square. So let's assign these values. So for that we have to select the floors. Go to assign shell loads uniform. Here you have to select the load pattern as a live, give the value 2 and direction, that is gravity downward, apply and OK. So now you can see 2 kilonewton per meter square live load is applied. Now for staircase, code says you have to apply a live load of 3 kilonewton per meter square. So we have to select the slab, go to assign shell loads uniform, here type 3 gravity pattern live, apply and OK. Now you can see it is 3 kilonewton per meter square. Okay. Now we have finished the dead load, that is self-fed, second live load. Now there is another category of load pattern is that is superimposed dead load. So what it includes? So after completing the slab, we put sand, cement and tiles over our concrete floor. Okay, so that load we need to add. So that load comes under floor finish. So the finishing material above the slab. Okay, so construction site, after completion of RCC slab, we put cushioning material, that is sand, mortar bed, and above that we put the floor. Okay, so this is the general way flooring in RCC slab. There will be sand, cement and tiles. So together this we call this as a floor finish. So we have to consider this load. In practice, the range for floor finish varies from 1 kilonewton to 2 kilonewton per meter square. Okay, so we'll use 1.5 kilonewton per meter square, or if you want to calculate, you can even calculate in details using IS 875 part 1. So we will take the value 1.5 kilonewton per meter square. Okay, so I will clear this. Let's open our ETAB model. In ETAB model, we have to put the superimposed dead load. So we'll select the floors. We'll keep this bathroom and toilet separate because there are sunken slab. So sunken slab has some additional load. So we'll calculate it separately. So before that, go to define, go to load pattern, and here we have to create the load case superimposed dead load and select here category super dead. Add this new load. Okay, now already we have selected these slabs. Go to assign, shell load uniform, select the category superimposed dead load, assign the value 1.5, keep the direction gravity, apply and OK. Okay. Now we have to calculate the load for toilet bathroom. So for that, if you have seen any under construction work, at that time what happens for the toilet bathroom, the level of the slab is generally lower. Okay, so suppose this is the general floor level, then this is the floor level for sunken slab. Okay, so what we do, we fill this material, we fill this place by the filling material. Okay, so you can even search on Google to check what is sunken slab. Okay, so in our case, this depth of the beam is 300. Okay, and we have considered the depth of the slab as 120. Okay, So if you calculate this, we'll get a 180 mm clear depth. Okay, that means this depth will be 180. Okay, so we have to fill this. So we have to calculate the load. So I will clear all these things first. Okay, so how to calculate the filler load? So filler load is basically a floor area load. It is like a pressure kilonewton per meter square, and we put cinders. Okay, you can even get the value for the cinder from IS 875 part 1. Broken bricks. Here you can see we use the broken bricks cinder. The density is 7.85. Okay, so here you can see density is 7.85. So we calculate this load per meter square, kilonewton per meter square. So volume, in volume we will consider the depth. So in our case the depth is 0.18. We'll calculate the load per meter square. So multiply by 1 into 1 for per meter square into the density of the cinder 7.85. Okay, if we calculate this, we get the value. I'll just open the calculator. 0.18 into 7.85 into 1 into 1. So this value is 1.413 plus the additional 1.5 load, that is it will become 2.913 kilonewton per meter square. So for these slabs the super dead load will be 2.913. Click on apply, click on OK. Okay, so this is how we calculate the load using the code book. Okay, now the another load remaining, that is the load on the beams, that is the load of the wall. Okay, that is masonry wall load. So for external wall we use 9-inch wall, 9-inch thick brick wall, that is 230 mm considering the mortar. Okay, and for interior or partition it is 4-inch 115 mm, and this is I am talking about the clay bricks. There are other bricks available like cement bricks, blocks are available, so you can calculate for those accordingly. Okay, so how to calculate that load of masonry? I will show you for external wall. So our floor to floor height is 3 meter, out of which you have to subtract the depth of the beam. Okay, in our case the depth of the beam is 300 mm. Okay, so our calculation will be 0.23 is the thickness of the wall multiplied by height, 3 meter minus 0.3. Okay, that is the depth of the beam, or whatever in your case, into 1 into 20. Again, from where I have taken this value 20 for the density of the brick, it is from IS 875 part 1. So again we can go with the calculator for the calculation. So 3 minus 0.3, this is the, sorry, 3 minus 0.3, that is 2.7, multiply by 20 multiply by 0.23. 23. So 12.42 is the load on external beams. So to assign this, you have to select the external beams like this. Go to assign, frame load, distributed, select superimpose the dead load, and here uniform load. Okay, so how much the value? 12.42. Click on apply, click on OK. Similarly, you can calculate for interior also. For that, you have to select the interior beams. Go to assign, frame loads, distributed. So here 0.115 multiply by 2.7 multiply by 20. So 6.21 kilonewton per meter you can apply. Click on OK. So this is how we can apply the loads. Okay. The next step is, as I told you, we have to replicate this model. Okay. So first I'll close this types of loads. I will go to study material, building. Okay. So our building is G+1. Okay. Generally, ground floor is nothing but it is like a bay. Bay is distance between two columns. So ground floor is a distance between two floors. So here you can see this is our ground floor. This is our first floor. Okay. So this building is G+1. This is our foundation. Okay. This is ground. This is first floor and the terrace. Okay. Now generally what happen whenever a client asks us for the design of G+1, but considering safety or future expansion, we ask him that how many floors you want, so that our foundation is and columns are that much strong to carry the future extension load. Okay. Suppose he said that in future he may construct one floor. Okay. So we'll plan this, we'll design this as per G+2. So this is our ground, just a minute, yes. This is our ground floor, this is our first floor, this is our second floor, and this is the terrace. So above the terrace, there will be staircase headroom, okay, that we need to model. So this is the general elevation for this building. So before replicating, we have to check our model. If our model is okay, then we can go for replicating the floors. Okay. So you can open the ETAB model. Here, analyze, check model, and here you have to select everything. Okay. It will check everything. Click on OK. Model has been checked. No warning message were generated. That means our model is okay. There are no any duplicate nodes, beams like that. Floors are perfectly created. So now we can replicate. Okay. So no any error will get replicated. Otherwise, if there is any error and you are simultaneously working on other floors, then there will be a problem. So go to edit, edit stories and grade system, modify show. Okay, so here we have to edit this because our this is our ground floor, or we can say plinth level. Okay, now we'll add stories, keep existing story height. Okay, story height is 3 meter. How many number of stories we need to add? Okay, so you can see here we have created this story. So 1, 2, 3, 3 more stories we required. We have to insert above our ground or plinth load. Okay, replicate the new story from existing story. So you can click on OK. Yes. Now we can give the name. This is the ground floor. This is the first floor. This is second floor. And this is terrace. Okay. Generally our ground floor, that is this floor, is generally 1.5 meter above from the top of the footing. Okay. Generally it depends upon hard strata. So you can change the height here 1.5, right? Click on OK. Click on OK. Now using this arrow, you can move up and down on the floors. Here you can see as we are changing, we are coming down. Okay, so this is our footing base level. Now we have to assign the fixed support. So just drag this. So all the column joints at the level 0 are selected. Go to assign joints restraints. Here fast restraint, that is fixed. Click on apply. Click on OK. So fixed support is been assigned. Now you can come to our ground floor plinth level. So one more thing to notice, that on the ground floor or at the plinth level, we don't construct the slabs. Generally it rests on our ground. Okay, so we have to delete these slabs. So we'll select these slabs and press delete button. Okay, there will be staircase slab because this is the landing or this is the staircase slab will be there. Okay, now this is our first floor. Here you have to select, you have to check the loads are replicated or not. So let's check. Yes, that is the beauty. We don't just copy the members like column beam slabs. Along with that, we have copied all the loading part. So even you can see here, all the loads are being replicated to all the floors. Okay, that is a great thing. Okay, now let's go to terrace floor, because at this terrace floor the loading will be slightly different. First thing, on the terrace there will be parapet wall only. Okay, and no interior walls are there. So we have to delete the interior walls, and for exterior there will be parapet wall, that is 0.9 to 1 meter height wall will be there. So first of all I will select the interior walls. Okay, here there is a staircase. Okay, there will be, above that there will be headroom. So we are not going to delete this part, we will keep this. Okay, so go to assign frame loads distributed. Here delete existing load, apply. Okay, now we'll select these beams. Okay, so here you can see for parapet there will be zero point 0.9 or 1 meter height wall will be there. So we will consider 0.9, 0.23 because it is at the outer. So 0.23 thick wall into 20. So 4.14 kilonewton per meter load we have to apply. So beams we have already selected. Go to assign frame loads distributed. Now here we have to type replace existing loads option is there. So 4.14, apply. Okay, now parapet wall load is been assigned. Okay, now at the terrace level the live load will be different. Okay, so sorry at the terrace you can reduce the live load, but sometimes what happen, we go for some function is there or some celebrations are there, some uh, sometimes people are there. Okay, for a function, so we may keep the live load 2 kilonewton per meter square on the terrace. Okay, now we have to recalculate the superimposed dead load because there won't be any tiles, there won't be any like floor tiles will be there, but there will be waterproofing. So we have to calculate the load of the waterproofing. So floor finish load on terrace. So dam proof course, terrace waterproofing. Okay, so there are multiple ways of waterproofing, so you have to consult with the contractor or what load should I consider, what you are going to do on the site. So let's assume that they are going to do the screed concrete. Generally the thickness of screed concrete is 2 inch to 4 inch, that is 50 mm to 100 mm thick. That is the waterproofing membrane and concrete. Okay, so let's assume the floor finish for the terrace waterproofing, that is 100 mm. 0.1 into 24 is the density. So we have to assign 2.4 kilonewton per meter square load. Okay, so go to, first I will clear this. So we'll select the slab. Okay, we have to assign shell load uniform 2.4, apply. Okay, so 2.4 kilonewton per meter square superimposed dead load will be there. Okay, you can change the value of live load depending upon your experience, because you can shift to 1.5 kilonewton per meter square or you can keep 2 kilonewton per meter square. Okay, now the last thing is staircase headroom. Okay, uh, so what we'll do, will replicate this floor and then we will delete. Okay, that is good way. So go to edit, storage and grid system, modify. We'll copy, add story, keep existing story, 3 meter. Okay. So we'll name this as a staircase headroom. Click on OK. Click on OK. Now we are at the staircase headroom level. Here you can see 13.5 meter. Okay. So we have to delete all these because there will be only staircase headroom. We have to delete all these beams also. Yes, there will be only staircase headroom. Now there won't be any one-way slab. Okay, this is a normal slab, flat slab will be there. Okay, so we have to go to assign shell slab section. A normal slab will be there, 120 mm two-way slab. Okay, above that there is no need to place any load. So you can delete this live load also. If we are not providing any access, then no need to have any load. So we'll delete, select this slab. Sorry, before that we have to delete this beam which is remaining. Select this slab, go to assign shell load, uniform. We'll remove the load. Okay. Superimpose dead load also not required here. If you want, if you can keep here that load also, and again no need to have the wall load. So we'll delete the load. Okay, so this is how you can have your complete model. You can see it in 3D. Okay, and this is the plan view with all the loadings. Right, now the next step will be analysis and designing. And modeling part is over. We have assigned the support conditions to the base. Now we can analyze our structure. So to before analysis, we can define the load combinations also. I will show you one combination how to define. Accordingly you can define other also. So give the name for load combination dead load plus live load plus superimposed dead load or SIDL. Linear combination, linear add. Now we have to assign the scale factor. Dead, live, and then SIDL. So this is how you can define the load combination. Now we'll analyze our structure. Before that you can check your model. If there is any warning, then ETAB will show. Here you can see model has been checked, no warning message were generated. Now you can go to analyze and run analyze. So in this part we will see how to check SFD, BMD of the structure, support reactions, footing reactions, then how we can uh, see that the results are correct or not. Okay, to check that we can go to display forces stresses diagram frame. Here you can select any particular case, load case, or you can select the load combination. Okay, let's see the result for superimposed dead load and for movement 3 3 and shear 2 2. These are the major results, and you can even click show values at control station, apply. Okay, now here you can see the results. You can even go to elevation. You can check the results for different elevation. Okay, this is the typical fixed beam diagram. Here we have provided simply supported, so you can check at fifth elevation, 5 number, apply. Okay, yes, so this is again we have provided this beam as a simply supported, and the shape you can see. That means the analysis, the way we have put the things are correct. Okay, similarly you can see the results for shear. So you can go to display shear 2 2. You can change the case. If you want to see for combination, you can see for combination. You can see the results for shear. Even you can go for 3D diagram. Yes, or if you want to see the elevation you can see. So these are the values of shear. We have just seen bending moments. Even you can see by right clicking on the beam, you can see the geometry details, then properties, beam section, what are the loads coming onto the structure. Okay, here on beam we can go here. So uniform force is there, design we haven't performed. So this is how you can check other things. Then you can see the support reactions for combination. If you want to see all 6 results you can see, or if you want to check only Fy, sorry Fz, you can check that also. So here you can see these are the footing reactions. If you select the moment, you can see the movements also. Even you can see all 6 results, right? If right clicking the member, you can see the shear force, bending moment diagram, and deflection. for the selected case. So this is how you can verify your results. Now we will see the design part. Okay, so come to design. This is our concrete frame design. Here select design combination. Okay, go to design concrete frame. Here you can see your design code and all other things you can check here. If you want to design the beams, you can select object type, beams, select clothes. So all the beams are selected. Go to design concrete frame. Here view revise overrides. Here you can see the beam framing type ductile. If you want to design it as an ordinary, you can design. If you keep it ductile design will be done. So you can first will run the ductile design. Okay, design combination is already set. Now you can click on start design check. Now ETAB will design each beam. It will tell which beams are failing, where they are failing. Will Yes, ETAB has designed our beams. Here this is the 3D view. You can go to design concrete frame design. Here you can see verify all member passed. So it will tell 48 concrete frames have not yet been checked. Okay, so these are the columns. Okay, we will design the columns also, or we will check it at later stage. So and this is the column reinforcement. So let's see, verify all members passed. All concrete members pass the design check, means whatever cross sections we have assigned uh, are okay. No need to change the cross section. Even you can check for lesser cross section if possible. So these are the results of the beam. So this is the beam, and 172 mm square is the reinforcement, 143 mm square, 175 mm square, 143, 165, 143. That means this is the beam, and above are the top reinforcement and below is the bottom reinforcement. Okay, similarly you can go to design concrete frame design, display design info. Okay, so right now it is longitudinal reinforcement. You can check the shear reinforcement. So it had shown the shear reinforcement. So basically this is 254.94. It represents the ratio of area upon spacing, and you can put your area by selecting two-legged 8 mm stirrup, and then you can calculate the spacing. Then here you can see rebar percentage. So how much percentage rebar I'll show one example here. So you can see here percentage of reinforcement used. So 1.7%, 2.78, 3.47%. So 3.47% still is so huge for the column. So you can basically increase the column size here so that it will be below 2%. Okay. For beam, you can see the percentage. You can check with maximum, minimum reinforcement percentage. So here you can see the display beam design also. Okay, so this is how you can check the results. Okay, 0.8% is the minimum reinforcement for the column. So wherever required, it has given the minimum reinforcement. Okay, so I hope the overall design of G+2 story structure is now clear to you. We have used all our IS codes for references like IS 875 part 1, part 2. I have shown you all the steps. So this is it. In next part, it will be dedicated to seismic analysis where we will cover equivalent static method, response spectrum method and time history analysis on this particular building. Okay, so please like, share, subscribe the channel, ask whatever doubts you have. I will surely reply. Thank you so much.